Hi everybody, this video covers section 1 of chapter 9 and we are going to get radical today. That's right, we're going to talk about roots and radicals. Specifically, we are going to evaluate square roots, we are going to evaluate cube roots, and then we're going to use the calculator to evaluate, square roots and cube roots. Well, actually not just cube roots, we're just going to restrict ourselves to square roots. Okay, so let's talk about some terminology or what we call nomenclature. This symbol here is called the radical sign. Actually, specifically, this is called the square root sign. The number under the radical sign is what we call the radicand, and the complete expression, such as the square root of 64 or something else that you have in your notes, is called a radical or a radical expression. And in this particular case, the radicand is, you guessed it, 64. In evaluating square roots, we are going to be looking a lot at perfect squares. And what is a perfect square? It is the square of an integer. So the perfect squares are basically 1 squared, 2 squared, 3 squared, all the way up to infinity squared if infinity is an integer, which is not, but the integer nearest to infinity, which we don't know what that is either. So example, 10 squared is 100, 11 squared is 121. These are all perfect squares. So what the heck is a square root? Well, if a number b when squared is equal to a, then we say that b is a square root of a. For example, if we take 4 and square it, we know that we get 16. As a consequence, 4 is a square root of 16. So we write this in mathematical notation. Square root of 16 is equal to 4. Similarly, if I took -4 and squared it, I would still get 16. So it turns out that -4 is also a square root of 16. And what does that tell you? Well, that tells you that every non-zero positive number has 2 square roots. The first one is what we call is the positive value, in this case positive 4, and we would call that the principal square root. The second one is going to be the negative of the absolute negative of that, and we would call that the negative square root. Fortunately for you guys, we are only interested in principal square roots. Now keep in mind, when we were talking about this, I interjected the word every positive number has 2 square roots. And actually, if it's positive, that implies that it's not 0, because a 0 is neither positive nor negative. Well, what happens if the number happens to be negative? Well, the negative number does indeed have a square root. However, that number is not a real number. So basically, the square root of -16, since that's the one we've been playing with, is not a real number. And why is that? Because there is no real number that if you square will produce for you a negative number. Whenever you take a number, no matter what it is, you multiply it by itself, you're always going to get a positive number. Accordingly, there is no way the square root of a negative number can actually have a real number for a solution. However, it does have a solution, and that solution is called an imaginary number. Why is it an imaginary number? Simply because it is not real. So the square root of -16 is an imaginary number called 4 times I, where I is the imaginary number. Of course, there's also another square root for -16, and that would be -4 times I. Okay? And of course, once again, I is what we call the imaginary number. Sometimes, in some professions, such as in my old profession, electrical engineering, we tend to use the number J for the imaginary number. And why is that? Because usually we use I for current. Okay, so let's do some examples. Let's evaluate the following radical expressions. The first one is the square root of 49. Now, you might recall that 7 times 7 is equal to 49, which means that 7 squared is equal to 49. So 7 squared is equal to 49. Then 7 is equal to the square root of 49. And also -7, but once again, as I mentioned before, we're only going to be interested in the principal square root. Okay, what about the square root of 121? Well, although I didn't have that in my list of tables, it turns out the next integer is 11, And 11 times 11 is equal to 121. So 11 squared is equal to 121. As a consequence, the square root of 121 is going to be equal to 11. Okay, what about 0? Well, 0 times 0 is equal to, you guessed it, 0. Therefore, 0 squared is equal to 0, and the square root of 0 is, you guess it, it is equal to 0. 0 is the only real number that has exactly one square root. And why is that? Because 0 is not a positive number. It's also not a negative number. Therefore, it does not qualify. It does not have the property that all positive numbers have. Okay, now what about 16 divided by 25? A little complicated? Well, maybe it is, maybe it isn't. So we know that 4 times 4 is equal to 16. And also, 5 divided by 5 is equal to 25. Well, that tells us that 4 squared divided by 5 squared is equal to 16 over 25. And we can actually use the power rule in reverse and say that 4 over 5, the entire thing squared, is once again equal to 16 over 25. Well, if that's the case, then the square root of 16 over 25 is, you guessed it, 4/5. It's also negative 4/5, but once again, we are only interested in the positive square root. Okay, so here's another set of examples. Here we want to evaluate some more square roots, and then for this one, for a couple of these, we are going to need a calculator, particularly for this one and for this one. Now for A, you might be tempted to use a calculator, and there's really no reason why you can't, but just notice that, well, if you took 0.04 and multiplied by itself, you would get 0.0016. Okay? If that's the case, well, then the square root of 0.0016 is going to be equal to 0.04, or 400ths. Well, we're looking for the negative of that, so this is going to be equal to negative 0.04. And remember, we are limiting ourselves to principal square roots, so we're not interested in the negative of the negative square root. Okay, now for the square root of 60, we would need to use a calculator. It is actually possible to use some tools to simplify that, but that is beyond the scope of this particular class. Instead, we actually want to use a calculator. And here's a calculator. Let me kind of put this over here. No, let's put it over here so you can actually see what we're doing. Okay, so we are going to take the square root of 60. How will we do that? Well, for this, it changes for different calculators. Unfortunately, I don't have my TI emulator up here, so I'm going to use my Windows calculator. I would type in 60. This little sign right here is a square root sign. I will click on that, and I will get this monstrosity of a number. Now, I only want this to 4 decimal places. However, I have a lot of these, so I'm going to have to do some rounding. So the first thing I'm going to want to do is basically write this down to, well, 5 decimal places. And that would be 7.74596. This is my 5th decimal place. I could go farther. Now notice here that my 5th decimal place is a number greater than 5, and that tells me I'm going to round up. I'm going to change this 9 to a 0, but since I'm going up to a 0, I need to change the 5 to a 6. So this will become, when rounded, 7.7460. That should be the answer. Okay, I don't believe the problems in your homework are nearly that bad. Okay, then the next one is -3 minus the square root of 45. Once again, we are going to need to use the calculator for that. So what is that going to look like? Well, let me get the calculator up here. Let's go up here. There we go. Let's go ahead and clear it. And then I'm going to do, for this particular calculator, I'm going to do 3. Oh, there it is. Minus, okay, that's my -3, minus then 45 square root. Now that number right there is a square root of 45. We don't have our answer yet. We need to hit equals, and that is our answer, which would kind of make sense. It's going to be 9.7082. This right here are our 4 decimal points right there. Okay, so that's basically what our answer. That basically, and notice the fifth one is a 0, so we don't need to round up, or we do not need to round up. So in this particular case, we are going to basically have 9.7082, and that would be our answer. Okay, the other thing we want to talk about are cubed roots. Okay, and basically cubed roots is really nothing more than an extension of square roots, except there is a bit of a twist. Okay, the definition is pretty much the same. If b cubed is equal to a, then b is the cubed root of a. And here's one example. Here we have, well, that should be 4 cubed, not 4 to the 4th power. That's bad. 4 cubed is equal to 4 multiplied by itself 3 times. 4 times 4 times 4. And if you do that, you would get 64. As a consequence, 4 is the cubed root of 64, and we will write this as follows. However, check this out. If I multiply negative 4 by itself 3 times, I'm going to get negative 4 times negative 4, which is positive 16, times negative 4, which is negative 64. So negative 4 is the cubed root of negative 64. And we can write it as follows. And as a consequence, even though negative numbers cannot have real valued square roots, they can indeed have real valued cube roots. As a matter of fact, if you are taking the odd root of any number, any negative number, you will always get a real valued solution. If you took the even root of any negative number, the solution will not be a real number. It will be an imaginary number. Okay, so what else? And with that, what else can we say? Okay, well, take a look at this expression here. This is the general expression for a radical. And the 3 here is an index, and that 3 can be replaced by any particular number, 4, 5, 5.8, believe it or not. However, when we're dealing with square roots, which is actually the most common radical that we deal with, we add no number there, because if no number exists, we know that 2 is being applied and it is not written. Okay, so that's just a little bit more nomenclature for you guys. So what do we have here? Well, here we want to evaluate some radical expressions. And the first one is the square root of 20, the cubed root of 27. Now we all know that 3 times 3 is equal to 9, right? And if you multiply that by 3, you're going to get 27. And that basically just tells us that 3 cubed is equal to 27. As a consequence, the cubed root of 27 is 3. What about this sucker right here? That looks pretty bizarre. Well, check this out. If I took negative 7 and multiplied it by negative 7, hang on, that's not right. If I took negative 7 and multiplied it by negative 7, I would actually get 49, and that's supposed to be a 7. If I multiplied that by negative 7 again, I would get negative 343. So that tells us that negative 7 cubed is equal to negative 343. And so the cubed root of negative 343 is negative 7. And then finally over here, I know that 5 times 5 is 25. If I multiply that by 25, I would get 125. And from up before, I know that 4 times 4 times 4 is equal to 64. And that tells me that 5 cubed divided by 4 cubed is equal to 125 over 64. And then I can rewrite that as 5 divided by 4 cubed. This is basically the power law in reverse. And that is equal to 125 over 64. And as a consequence, the cubed root of 125 over 64 is 5/4. Okay, that's all I have as far as the lecture portion is concerned. Sit tight, and we can do a few problems in Hawks. Okay, and here we are. Okay, let's start practicing. And true to form, they start us out with some of the tougher problems. Now, in this one, just remember that 9 times 9 is 81. And then, as we mentioned in the previous part, 11 times 11 is 121. Which means that this is equal to 9 divided by 11, the entire thing squared. And therefore, our answer is going to be 9/11ths. That's the square root of 81 over 121 is going to be 9 divided by 11. And then to put this in, we put in a 9, use our slash for fraction, and they have this interface, which means we need to tab down. Can't just see the arrow keys. Put in 11, submit our answer, and there we go. Let's see what else we have. Okay, this is one where we want to evaluate it. We want to express our integer as an integer, our answer as an integer, a simplified fraction, or as a decimal rounded to 2 decimal places. Okay, now this, as you can tell, is not a real square. So we probably need to use our calculator to figure this one out. So let's go ahead and do that. Or I'll put the calculator on the notepad side, and in this particular case, what I'm going to do is I'm going to put in 71. Well, first I'm going to clear 71, hit square root, which is this button right here, and that gives me 8.426. Okay, but we want it down to 2 decimal places. All right, so here's my 2 decimal places. My 3rd decimal place is a 6. So that means I want to move my 2 up to a 3. So my answer is going to be 8.43. And there you go. Okay, let's see what else we have. Okay, this is our first cubed root problem, and we've actually seen this one before. Remember, 4 times 4 times 4 is 64. So 4 cubed equals 64. Therefore, the cubed root of 64 is equal to 4. Now, you can also write the cubed root of 64 as this: 64 to the 1/3 power, which once again is still equal to 4. Okay, and here is a cubed root of a negative number. And recall that -3 times -3 times -3 is just a very long-winded way of saying -3 cubed. And -3 times -3 is positive 9, times -3 is, that should be 3 not a 2, is -27. Therefore, we know that the cubed root of -27 is -3. And apparently Hawks agrees. Okay, this actually, I believe, is a perfect square. But if we're not sure, what we can do is just find out using our calculator. So let's go ahead and do that. Let's put in, let's clear, put in 196, hit the square root button. I think we should get 16. No, we get 14. 16, 14, what's the difference? So here, the answer happens to be 14, so we're just going to put 14 in. And there we go. And let's see what else we got. We're actually halfway through all the problems. Okay, here we have the square root of a negative number. All right, if the radicand, or the thing inside the square root, is a negative number, then the solution is not a real number. The solution here, and as a consequence, we are going to click that. Okay, that occurs whenever we have the square root of a negative number. Now it turns out that the square root of -169 happens to be 13i, where once again I is the imaginary number, and it turns out that I is equal to the square root of -1. -1. There we go. That's what I was, well, I is equal to the square root of -1. There, that's better. Okay, and I think really that's all the stuff that we need to go over in this particular lesson. Let me just see what else there is here. No, actually, let's do this one as well. Remember, we have that 11 squared is equal to 121. Therefore, the square root of 121 is equal to 11. But we're looking for the negative. We're looking for the negative of the square root of 121. We're looking for this negative square root of 121. So we're going to have our 11, but we also need to include the negative sign, and that should be your answer. Okay, now let's take a look at this one right here. This is the square root of 4 plus 32. Before we evaluate the radical, we actually have to simplify what's inside, which we can. We can add them together. They're like terms. And we actually want to. Why? Well, because it turns out that 4 plus 32 is 36. And that's a perfect square, because 6 times 6 is equal to 36. Therefore, the square root of 36 is nothing more than, you guessed it, 6, which would be our answer. Okay, so that is pretty much how this particular lesson goes. As always, if you have any questions, please feel free to reach out to me, and I'll be happy to help. And this is Bob Oil, signing off.